Welcome to this tutorial on creating parts and assemblies in Inventor. We're going to join up an awful lot of work that we encountered in the last few tutorials, such as the Excel sheets linked to Inventor, skeletal modeling, etc. So the first thing I'm going to do here is just take a look at this Excel sheet. It creates all the parameters that we're going to be using, such as top length, top depth, bottom depth, etc. We're just going to look at one of these formulas as well. These pink cells are actually formulas created in Excel that will parametrically drive the finished assembly Inventor. So this is B2, which is the top depth, minus 2 times the front back step in of the gable. What this basically means is that the gable depth is going to be equal to the top minus the step of the front minus the step of the back. No matter what happens with all the other cells, these will remain constant with the actual parametric drawing itself. Just below the gable thickness here we have a bottom length as well. That's also in a pink cell and contains a formula. So the bottom length, the actual bottom part of the entire unit, is B4, which is the gable side step in, minus B8, which is the gable thickness, and both are multiplied by 2. Basically this means that the bottom length is the same as the top, minus the 2 gables combined, minus the step in to the 2 gables from the top combined. The bottom depth here is equal to B7, so basically the bottom depth is going to be the same as the gable depth, therefore they'll be flush on both the front and on the back. Referring back to the Inventor drawing, we're just going to create a standard part. Now the first thing we're going to do here is just to create the top. So we're just going to draw a rectangle using click and drag, manage, parameters, and we're going to link the Excel sheet now that we've already created. This is exactly the same steps we went through in previous tutorials. These parametrics, when they're inputted, they will drive our whole model and enable us to infinitely redefine the measurements, the parameters of the finished piece of furniture. So the first thing here now is just creating a dimension on the length, also the depth, and we just select these from the list of parameters as well as the occasion before. Now we're just going to perform a simple extrude. Just going to pick the top thickness, and this now can be saved as the top. I just found a new folder and placed this top as a part. Exactly the same steps again. We're just going to create a standard IPT, which is standard part. Click and drag of the rectangle. This is the gable of the table. So I'm just going to link the Excel sheet to the Inventor drawing once again. Inventor now calculates all the parametrics. Back into Sketch and dimension the gable. In this occasion it's the gable thickness, and a simple extrude. This part can now be saved again. And lastly, we're just going to create a standard IPT for the actual base itself. Once again, we must link the parameters, pick the Excel sheet, establish the link, and finally click Done. Back in the sketch environment again, we're just going to dimension the base. And now perform extrude once more. This can now be saved as a base, and now we're ready to commence our actual assembly drawing. So we're just going to click New and Standard IAM, which is a standard assembly. We can now click this button Place, which will place our parts in the assembly environment. So the first thing we have to do here now is basically find the parts. So I'm going to go into my folders and find the top of the table. And place it with a simple click. Escaping out of that, we can now go to Place and find the gable. We have only one part called a gable, as the two gables are completely identical. Therefore, when we actually have it in the assembly environment, we can simply just click twice and create two gables. The first thing now we're going to do here is just click Constrain, and this brings up a dialog box. The one that the icon is hovering over now is Mate, and the one to the right is Flush. So we're just going to click Mate. We're going to mate the top of the gable to the bottom of the top. At the present now, the two are mated, but the gable can still slide forward to back and left to right, so we must constrain this further, and we'll do this by using the flush constraints. So back to the dialog box, click Flush, and we want to flush the front of the gable to the front of the top. Now if you remember from the Excel sheet, there was a slight variation here. We have a front to back step in, which is the same on the front and on the back. So we're going to have to link the parametrics of the Excel sheet to the inventor drawing. So what we're going to have to go do here now is actually go to update the parameters. So Manage, Parameters, link to the Excel sheet once more, and select the Excel sheet. Now the parameters have been updated, we can go to Assemble, Constrain, Flush, pick the top, pick the gable. Now at the moment they are totally flush, but we do not want this, we want an offset, so we pick the offset. Since it came forward and not back, we have to be able to edit this. Since it came in the wrong direction, we just enter a simple negative value before the constraint. Now we can apply. Now the gable can actually move left to right, so we must also constrain it in this direction as well. The exact same operation will be carried out in the opposite gable. So now we can go back to Constrain again. I would click Flush, the outside of the gable to the edge of the top. Also now linking with our parameters. Pick the offset. It's gone the correct direction, as you can see from the drawing. Therefore we do not need to enter a negative value, we can simply apply and cancel. This gable now is fully constrained, so we can do the exact same operation on the opposite gable. Firstly, so we're going to mate the top of the gable to the bottom of the top. Then we're going to flush the front of the gable to the front of the top. Create our offset and apply. Finally, the same action must occur on the outside of the gable. So we're going to constrain, flush, the outside of gable, outside of top, and also apply our parametrics. These two gables and the top now are fully parametrically constrained. The next task to encounter is to place the bottom into the assembly. So go to Place once again, go into our folders and find the base. and click to drop in the assembly. Next we have to constrain it. So we're going to click flush the front edge to the front of the gable. Apply. Mate the end of the bottom to the inside of the gable. And finally we're going to flush the bottom to the bottom of the gable. This model now is totally parametric, and any changes in the Excel sheet will also reflect in the inventor drawing. So the next thing now we're going to do here is basically go back to our Excel sheet and edit some dimensions that will edit the drawing itself. So just take a quick look here at the drawing as it stands. Now back to the Excel sheet. But notice now that every time a dimension is changed here that directly reference the pink cells, which were the ones with the formulas, it will change them also. And we can finally save this Excel sheet, manage, and update the parameters. As you can see now, the same item of furniture, even though it's the same item in general, has actually changed in size and specifications. If I want to return to the Excel sheet and create some modifications, this will also reflect in the inventor drawing. Here now the gable depth has gone to minus 375, which means that it will not correspond correctly to the inventor drawing, therefore an error must have been inputted. Even though this is one of the most basic of drawings in Inventor due to of skeleton modelling, it also shows the capabilities of the program itself. This could be used in different applications in different industries for different products. Therefore, it's a very useful tool in visualizing an end product, and particularly where products are made of the same material but need to be made of different sizes and specifications.